All right, ladies and gentlemen, time to continue our Module 4 notes. Today's lesson is going to be Module 4, Lesson 8. We're going to talk about two more ways to multiply fractions. Specifically, two ways to multiply a fraction by a whole number. By a whole number. This is getting kind of long, but that's okay. We'll stretch into the margin a little bit. Two more ways to multiply a fraction by a whole number. This is Lesson 8. So we need a 5, 6, 7, 8. Our Roman numeral 8 right there. Okay. Now yesterday, in Lesson 4-7, we talked about using a tape diagram to multiply. That obviously still works, but when the numbers get bigger, sometimes drawing a tape diagram is inconvenient. So there are a few other ways we can do it. This first way, probably not my first choice, but I think for some of you, you're going to like this one. You can just use addition. Now again, when the numbers start getting bigger, this starts to become very inconvenient, but for smaller values, it's not too bad. Let's say I am looking at 3 times 1/2. 3 times 1/2. Well, that would just be 1/2 3 times. So 1, 2, 3. Now because we're multiplying, we are combining these together, which means it's the same as adding. It's one of the first things you learn about multiplication is it's really just a faster way to add. So 1/2 plus 1/2 plus 1/2 equals 3 halves. That looks familiar. If we were to change that into a mixed number, we would have 1 and 1/2. Tape diagram helps us visualize this. We won't draw one right now. But if you can imagine these two halves coming together as a whole, plus another half, or maybe these are the whole and that's a half, whatever works. Let's say we have something a little bit different though. Let's say we've got 2/5 times 5. Oh no, I switched the order. Commutative property of multiplication tells us we can switch the order. It doesn't matter. We'll still multiply and work this out the same way. Now, this also, if it said 2/5 of 5, it would work the same way. 1, 2, 3, 4, 5. Just add them all together. We are combining them. There we go. Some of my addition symbols, not the best. I will blame my pencil as I always do. 2, 4, 6, 8, 10. Thank you, pencil. 10 over, going to a regular pencil today, 10 over 5. Now remember, when we're adding fractions, I didn't say it up here, the denominator is always going to stay the same. Denominator, denominator stays the same. This is just telling you the size of the pieces. Now if I have 10/5, every group of 5/5 will make a whole. I can make 2 wholes from that. This one's a little trickier to see because 2 plus 2 is 4, plus another 2 is 6. That would be 1 and 1/5. Yeah, it's not quite as easy as that one was to see, but hopefully you're getting the pattern. Now, hopefully you're also noticing another pattern. We went from 3 to 3, 5 to 10. Why 5 to 10? Let's look at our next strategy. We can take a little bit of a shortcut and simply multiply the whole number times the numerator. Crazy. If you look back up here, 3 times 1 is 3. 5, there's our whole number, times 2. 5 times 2 is 10. Okay. And I'll show you with that exact same problem. Let's go ahead and do that. 2/5 times 5 is equal to 2 times 5 over whatever the denominator was. Okay. We know 2 times 5 is equal to 10. And just like before, that's going to give us 2. Okay. Now you want to be very careful. I'm going to put a note here. I'm going to put some arrows. Oh yeah. The denominator stays the same. We're going to talk about that more later when we start multiplying fractions times fraction. But for right now, just remember, if you're using this strategy and you are going to practice it in class, numerator times whole number times numerator, multiply those two together, but the denominator carries over. That stays the same. That stays the same. All right, let me give you one that's brand new. Let's take a look at 5/6 of 30. Now see, this is one where actually a tape diagram wouldn't be too bad here, but addition, that would be pretty miserable. You would have to write this 30 times. I don't think any of us are interested in that. Now, I am going to look at this, and the first thing I'm going to do is remember, when I see of, specifically a fraction of, that means multiply. We're multiplying. So 5/6 of 30 is the same as 5/6 times 30. And using our strategy, we know we can multiply numerator times whole number, 5 times 30. Denominator stays the same. And then we're going to get a fairly large number here. We're going to get 5 times 30. Well, 5 times 3 is 15. Put the 0 on. 150 divided by 6. 150 over 6. And I went a little ahead of myself there. 150 over 6, because I'm already realizing we're going to need to do some long division here to simplify that. 150, remember numerator goes on the inside. Let me slide this up a little bit. Numerator goes on the inside. Denominator goes on the bottom. 150 divided by 6. 6 will go into 1, no times. 6 will go into 15 twice. 2 times 6 is 12. 15 minus 12 is 3. We'll bring down the 0. 6 will go into 35 times. 5 times 6 is 30. We'll go ahead and bring that down. So our final answer, 150 over 6, that is going to be equal, and I know it's right there in the quotient of our division, but you know how much I love boxing things. 5/6 of 30 is 25. 5/6 of 30 is 25. Now, I said we wouldn't be doing too many tape diagrams, but we are going to do at least one because I want to show you the connection. I can hear your collective groans. even through YouTube. You'll make it through. Go ahead and draw your tape. We need to think of what the whole is. What are we starting with? 30. I know this comes first, but remember, we're trying to find 5/6 of some bigger amount. So that is the amount we're going to be dealing with. 5/6 of 30. Sixths. The denominator tells me how many pieces I'm going to break this into. Let's make sure I did that correctly. 1, 2, 3, 4, 5, 6. Okay. Now, hopefully, most of us are already thinking, well, 30 divided by 6. Okay. That's going to be 5, 5, 5, 5, 5, 5. Each of these pieces will be 5. I want 5 of them. Can't have stray marks on the notes. Come on, Mr. Long. Really? We can do that? Okay. Let's try that again. If you look at a single 1/6 of 30 is equal to 5, well, 1, 2, 3, 4, 5 of them, 5/6 will be 5, 10, 15, 20, 25. Same answer, just a slightly different strategy. Okay. Now, on your activity for Lesson 8, you are going to be given a problem and asked to solve it in 2 ways. So for example, slide this up a bit. Okay. If I were to give you 3/4 times 60, 3/4 times 60, you would be solving this 2 ways. You could use the tape diagram, you could use addition. I would not use addition. Or you could go through and use the multiplying the numerator times the whole number. For this particular example, that's the one I'm going to pick. I will also say most of your examples will be significantly smaller, 3/4 times 6. But I'll do one more of these big ones with you on the notes, so please copy this down. Numerator times whole number over the same denominator. 3 times 60 is going to be 180. 3 times 6 is 18, plus the 0, over 4. Whew, and then we've got some division to do. Now, depending on how comfortable you are with your multiplication facts and simplifying, we can actually do a little bit of simplifying here. We can divide the top and the bottom by 2 and get it down to 90 over 2. 90 divided by 2 for some of us might be something we already know, but we'll go ahead and we'll do the whole thing. I'm going to scoot up a little bit to make sure I have room here. 180 divided by 4. 4 will go into 1, no times. 4 will go into 18 4 times. 4 times 4 being 16. 18 minus 16 is 2. Bring down the 0. 4 will go into 25 times. 5 times 4 is 20. Subtract that out. It works out very nicely. 3/4 of 60. 3/4 times 60 would be 45. Whenever I see 60, especially if I see quarters, 3/4, 3/4, I'm thinking about time. Think about 3/4 of an hour. 60 minutes in an hour. 3/4 of that, 3/4 of that would be 45 minutes. 1/4 of an hour is 15 minutes. This is if we're using the tape diagram, you'd have 15. So 3 times 15 would also be 45. 15 plus 15 being 30. 30 plus 15. I think you folks get the idea. If you have any questions, as always, make sure you make a note of them. We'll go over them in class. I'm hoping that after the practice we've done with arrays, with all these different things, you're feeling a little more comfortable playing with the numbers, playing with the fractions. that's really what this part of the module is about, just getting comfortable with the way fractions interact and work together. We'll go ahead and stop here. Again, any questions, bring to class, and I'll see you there. Thank you, ladies and gentlemen.